Alright, so we've got the function f, x squared plus 2, that is the top function there, and g of x, x squared minus 2x, which if you factored it, you find those x-intercepts of 0 and 2. And it has two regions there, the region R and S labeled. So R is the region bounded by f and g from 0 to 2. Right, but do not evaluate an integral expression that gives that area. So we're going to do top function minus bottom function from 0 to 2. Maybe. Wow. That was weird. Well, that's why. Hard to make smiley faces. Oh, my back button. Okay.
Well, I'm not helping. I'm literally like, not even a tech, I'm the guy you invited to the
I'm actually like forced to leave the house at 7
Yeah, I probably shouldn't just fly around. I actually. Yeah, I got my house to
You know that
Happiness is working. Yeah. Okay. So you just take f of x minus g of x, no problem there. So often in these long answer questions, it starts off with something relatively straightforward, and then the questions will get a little bit more complicated as we go. So now S is the region under g of x from 2 to 5, as shown. That region is the base of a solid. Cross sections perpendicular to the x-axis, so draw that line there so that you know that those sections are going from left to right, with a rectangle with height half the base of its region. Find the volume of the solid, show your work. So we're going to go from 2 to 5. The width is g of x, the height is half of its width, so it would be half of g of x. And we want to find this solid, so we're going to plug things in here, and you would get x squared minus 2x squared, which we can't integrate this in this form right now because it would, like, if you think derivative-wise, it would have a chain rule with functions inside, so we actually have to expand it. I can bring that half out in front. Now everything is relatively easy integrals. And this is enough work. You do not have to do anything further than that. Once you plug in those numbers, no simplification is needed, but for us, we like to show a final answer. You get no marks for the simplification. But I'll let you write that. Everybody good? Almost? And then part C, again, asks us to write but not evaluate an integral expression that gives the volume of the solid generated when the region S is rotated around the horizontal line y equals 20. So here's y equals 20. Okay. This is the region S that we're rotating. So again, we have to think about this shape and how big its radius is. Okay? So the big radius, right? It's going to have a washer, right? If I take a section like this right here, it's going to be open like this and open like that. There's going to be a washer that gets made. So we have to think about our big radius and our little radius. Now our big radius is kind of nice. It's always going to be 20. Can you see that your big radius is 20? But then our small radius here, so our big radius right here is always going to be 20. Our small radius here, how do we calculate that? It's going to be 20 minus whatever g of x was. So when we go to write this out, here's our big radius. I'll put a big R over this one. Again, pi r squared minus pi. Here's our little radius. So sometimes they're nice, I'd say they're nice on the exam because could you evaluate this? Yes. Would it be super annoying with a bunch of little algebra stuff to do along the way? Absolutely. If they got you to evaluate it and you did all that little algebra stuff, what's that going to do? It's going to take you a lot of time. Right? So first of all, make sure you read the question carefully. Because if it says, do not evaluate, it would be a bad choice to spend 20 minutes evaluating this question, where step one got you all the marks for this question. And the rest of your work just showed you didn't read it very well. Okay, so this is all we'll do for today. Stop the video here.